Hi everyone. Today we're going to talk to you a little bit about something called a combination. Okay, so we want to go through here. It's goes along with the topic of factorials and permutations. And at the top here, I put a little reminder note of where on the graphing calculator you can find both the factorial and the formula for calculating permutations. Also remember, permutations, when you calculate, order matters. There's something in the problem, okay, or your situation that is going to indicate that some kind of an order is going to be important. Combinations, on the other hand, as you see here, combinations, order or arrangement, not important. So any old way we organize things, we're able to do that. Order doesn't matter. So AB and BA, okay, are going to be different. All right, so let's keep going here. So I gave you a little formula here. NCR. You'll notice it is similar to the permutation formula, except that we have an extra divide by R factorial. N is still going to be the total objects that you have. R is how many you choose. Okay, number of objects chosen at a time. Yeah, we'll get this out of here. Number chosen. Okay. When we calculate, you are certainly welcome to use the formula, but I'm going to encourage you to use your math prob. And this time, if you're in there, you'll see choice number 3 happens to be your NCR. Okay, so let's go for an example here. Given the letters A, B, C, D, how many combinations of 2 letters are possible? Okay, well, you've got 4 letters, and we want to choose 2 at a time. So if you plug that in your calculator, you'll go 4, and then math prob 3 for NCR, and then tell it 2, and when you press enter, it should tell you there are 6 ways to organize those letters. Okay, while you're in there, let's do again. Let's do a 5 NCR 5. Press enter. You should come up with a 1. Okay. In fact, if you do where the N and the R are the same at any time on a combination, it's always going to come out to be 1. You're welcome to give that a try. See if that works out. Okay, and again, I just threw another one on here to try with your calculator. 8 NCR3. If you plug that in your calculator, you should get 56. Okay, so again, I just wanted to make sure you're able to type those in correctly and feel comfortable getting the correct answer. All right, example 3. To survey customers at a local mall, a researcher decides to select 5 malls from a total of 12 malls. How many different ways can the selection be made? Okay, well, we've got 12 malls. We want to choose 5 of them. No ranking, no order implied. So we'll just go with the C. Loading that in the calculator, we can certainly do that. If you're into doing formula, you can do 12 factorial divided by 12 minus 5, parenthesis factorial, divide by 5 factorial. Just for fun, thought I'd show you that. Okay, answer either way should be 792 arrangements. All right, let's try example 4. In a club, there are 7 women and 5 men. A committee of 3 women and, in fact, I'm going to underline this, 3 women and 2 men is to be chosen. How many possibilities are there? Okay, well, whenever we have an and is going to be an implied that we want to multiply our 2 values together, okay, as far as the way to choose the number of women and the way to choose the number of men. Okay, so let's do this. How many ways are there to choose the number of ways to choose the women? Well, I noticed that there were 7 women, and we want to choose 3 of them. Okay, so then what is the number of ways to choose the men? Well, we have 5 men. We need to choose 2 of them. Okay, and it says to do an and it's going to tell me to multiply those 2 values together. Okay, so individually, I come up with 35 times 10. So that tells me there are 350 ways to select that committee. Okay, all right, let's try this example 5. This one's a little tougher. It says a committee of 5 people must be selected from 5 men and 8 women. Okay, so there's our totals. 5 men, 8 women. How many ways can selection be done if there are at least 3 women on the committee? Okay, and we need a total of 5 people. And we want at least 3 women. All right, so our committee, okay, can look like this. The minimum number of women we want is 3. So, sorry, a little mistake there. Okay, so we can have 3 women. Okay, if I have 3 women, then how many men would there be? Because I need 5 people, remember. Okay, I think I hear you out there saying there'd be 2 men. Okay, or since I have at least, I could have 4 women on the committee. Okay, 4 women, then I would have 1 man. Okay, or we could have all 5 women on the committee and 0 men. Okay, so a little bit of this that you may feel uncomfortable is, okay, so I have these ors. What does that mean? Well, whenever you see an or, that means we're going to be doing some addition. Okay, and if we're doing 3 women and 2 men, that's going to be an implied multiplication, like in the previous example. All right, so let's take a look here. To choose women. There's 8 women in the club or in the group. So I have 8 women and I have to choose 3. And then I'm going to have 5 men and I choose 2. Okay. The second scenario is I have 8 women total. I need to select 4, choose 4. For the men, I have 5 men total and I'm choosing 1. And the last one is I have 8 women, choose 5. And then I have 5 men, choose 0. Okay. So if we do these individually and multiply them out, okay, the first one comes out to be 560 ways, plus the second one should be 350, plus the last one here is 56, and if you get a total, there are 966 ways to select that committee. That's a lot of thinking for those people picking that committee. Okay, and again, all of this happened because of this at least right here. Okay, that's why I had to have these 3 scenarios to add up. Okay, all right, lastly, this is kind of a bonus, and I have it on my guided notes, so I'll show you how to do this. We haven't talked much about decks of cards with your probabilities at this point. Okay, but here's the deal. It says how many different 5-card flushes are there in a standard deck of cards? Okay, so I'm relying on you knowing what a flush is and also what a standard deck of cards is. Okay, so standard deck of cards is simply 52 cards. Common deck of 52 cards. And I know some of you don't play cards much anymore, but okay, so that's our deal. A flush means that you are going to have 5 cards of the same suit. Okay, 5 cards, same suit. Okay, so what that means is, well, let's see if I can do all this. You have 4 suits. Maybe I better write this to the side. This is a little ahead of us for some of you guys. 4 suits, which means there are 13 cards of each suit. If you play cards, you're aware of this. Okay. So here's our scenario. I have 13 cards in a suit and I have to choose 5 of them. Any 5, because a flush is 5 cards, same suit. All right, so if I do a 13C5, I get 1,287 flushes. And I should say for each suit. So if I want it for the whole deck of cards, which is what it says over there, I have to multiply that number by 4 because there are 4 suits in that standard deck of cards. So in the end, there are 5,148 flushes in a deck of cards. So I'm going to say that equals the number of 5 card flushes in a deck of cards. Okay, that one, not super exciting that you have to know that, but it made a nice place to put a combination. Hey, one other thought. If you're doing a combination, like in the days when it's normal time, and you might be able to like use your locker, okay? Do you have a locker combination or permutation? When you get in your locker, does the order matter that you spin your lock, or does the order not matter when you spin your lock? Okay, hopefully you're kind of thinking about that and say, oh, well, the order matters. Somebody gave me a 3-number code. That's how I get in my locker. Well, if that order matters when you put first number, second number, third number, you have a locker permutation. On that note, I'll be signing off. Have a great time with your permutations and now your combinations to go with that. We'll see ya.